Hello everyone, welcome to sci-chem. Hope all of you are doing good. Today we are going to start a new topic in physical chemistry, that is paper course 6, and the topic is chemical kinetics, and it is the lecture 1. So before starting chemical kinetics, we have to know what is rate of reaction. So what is chemical kinetics? Chemical kinetics is the main branch of physical chemistry which deals with study of rate of reaction as well as to determine the mechanism of a chemical reaction. So what is rate of reaction? The rate of reaction may be defined as the change in concentration of reactant or product per unit time. The change in concentration of any of the reactant or product per unit time is called rate of reaction. So here the rate of reaction is equal to change in concentration of reactant or product per time taken. So in order to know what is rate of reaction, let us consider a reaction A gives rise to B. Here A gives rise to B. So when time t is equal to 0, we have concentration of A, that is A naught. Since at a time t is equal to 0, there is no product is being formed, so concentration of B is 0. When time t is equal to t, that means after some time, it may be 5 minutes, 10 minutes or 25 minutes, etc. Let us consider the final concentration will be AT. And the final concentration of B will be BT. So what happens here? So since the reaction is A gives rise to B, that means A is here 1 mole and B is also here 1 mole, that means the reaction is 1:1 proportion. So I can say that 1 mole of A will react with 1 mole of A will react to give 1 mole of B. So if X amount of capital A is dissociated, then I can say that the remaining amount or AT, the final concentration will be AT is equal to A naught minus X, and BT equal to X. Since the reaction is 1:1 proportion, so when 1 mole of A will react, then 1 mole of B will be formed. So if X is the amount of A dissociated, then X amount of B will also be formed. So AT is equal to A naught minus X and BT is equal to X. So these are the terms that are usually involved in regarding kinetics. So I can write here rate of reaction of A may be written as rate of A or rate of disappearance or rate of consumption. that will be equal to change in concentration of A divided by time taken. Change in concentration of A. The final concentration is given here AT and the initial concentration is A0. So I can say that AT minus A0 divided by T minus 0. So since here AT is less than A0, so AT minus A0 will be negative of AT minus A0 by T. Why there is a minus sign? Because rate does not have negative value. So change in concentration I can write as minus delta A by delta T. This is rate of change of concentration of A. This is rate of change of concentration of A. Why there is a minus sign? The minus sign is due to, since the rate does not have negative value, in order to make the rate positive, so we have to multiply by minus sign. So in the similar way, so here again rate of change of concentration of A can be written as minus delta A by delta T. Why there is a minus sign? Because rate does not have negative value. Similarly, the rate of B, here the rate of B can also be written as rate of production or rate of appearance. For A it is disappearance and for B it is appearance. So I can simply write delta B by delta T is equal to change in concentration of B divided by time taken. So change in concentration, final minus initial concentration, Bt minus 0 divided by T. Since the concentration of Bt greater than 0, so there is no negative sign is used. So in other words, I can write the rate of B is plus delta B by delta T. So this is delta minus delta A by delta T is rate of A and plus delta B by delta T is rate of B. or in other words, change in concentration of A is also called rate of A or rate of consumption or rate of disappearance, whereas change in concentration of B is also called rate of B or rate of production of B or rate of appearance of B. In the similar way, I can explain the rate of any individual product. Let us consider if there is a given rate of C. If C is a reactant, then I can write minus dC by dt. If I have to write rate of D, if D is a product, I have to write plus d by dt. What is the difference between D and delta? The difference between D and delta is D is for small change and delta is for large change. So while explaining, here while explaining the rate of any reactant or product, we don't require the stoichiometry coefficient. What is stoichiometric coefficient? These are the numbers which are required to balance a chemical reaction. So for writing rate of a reaction or any individual reaction, I have written here the rate of CR is and the rate of D. C is the reactant, D is the product. Since for any reactant or product, any individual product, for rate of any particular substance, its stoichiometric coefficient will not be required. So this is all regarding a rate of a chemical reaction. Next, come to next part. Unit of rate. What is unit of rate? So simply I have rate is equal to change in concentration divided by time. So we know that concentration have unit mole per liter. So for writing rate of a chemical reaction, I have two cases, that is case 1 for aqueous phase, rate is equal to mole per liter divided by time. Here time may be in second, minute, hour. Case 2 for gaseous phase. For gaseous phase, the change in concentration is always in terms of atmosphere pressure. So rate is equal to change in pressure divided by time. So unit of rate here is atm per time. Time may be in second or minute. So the unit of rate, that is mole per liter mole per liter, unit of concentration is, so the unit of rate is mole per liter per time, and time is second, minute inverse or hour inverse, or simply I can write that molarity second inverse. Why it is molarity? For m, molarity is the mole per liter, and if the reactant and product are in gaseous phase, I can write here that the unit of rate will be atmosphere per time, that is change in pressure per time. So that is the unit of rate. Then come to next part, dependence of rate on stoichiometry. How rate of a chemical reaction depends upon stoichiometry coefficient. So in order to know about this concept, we have to consider a reaction 2A gives rise to 3B. So when, let us consider 2A gives rise to 3B, that means here the coefficient is 2 and here the coefficient is 3. So let us consider a reaction 2A gives rise to 3B. So what happens here, since the stoichiometry is for A it is 2 and for B it is 3, when T is equal to 0, the initial concentration of A will be A0, and after some time T is equal to T, the final concentration will be A0 minus, consider previous example A gives rise to B. Since there is 1:1 proportion, that means when 1 mole of A will react with 1 mole of A react, then 1 mole of B will be formed. So when T is equal to 0, we have here A0 and here 0 concentration. When T is equal to T, we have A0 minus X. What is X? X is the amount that is dissociated from B. So since the reaction is 1:1 proportion, that means 1 mole of A, so X amount will be dissociated and 1 mole of B is formed, the X amount of B will be formed. But here the stoichiometry is different. The stoichiometry here is 2 and here it is 3. So here 2x amount will be dissociated and 3x amount will be formed, so that it is AT and it is BT. Since 2 mole of A react to form 3 mole of B, 2 mole of A, so 2x amount will be dissociated and 3x amount will be formed. So here I can write rate of A is equal to minus dA by dt is equal to minus d by dt, that is minus d by dt, that is change in concentration. What is the final concentration? A0 minus 2x minus A0 divided by T. So here I can write minus d by dt of A0, A0 will be cancelled, so here I can write minus 2x by T, or in other words 2 dx by dt, then that is the value of minus dA by dt. In similar way, rate of B is equal to plus dB by dt equal to plus d by dt of 3x minus 0 by t, that will be equal to 3 dx by dt, and it have the value plus dB by dt. When there is a gives rise to b, when t is equal to 0, it have concentration a naught. Again I am telling, again a naught, it is 0. When t is equal to t, it is at, and it is bt, it is a naught minus x, and it is x. So minus dA by dt is equal to a naught minus x minus a naught divided by t. There is a minus sign, so equal to dx by dt, and plus dB by dt is equal to x minus 0 by t. It is also dx by dt. So since the reaction is in 1:1 proportion, I can overall write rate of reaction equal to dx by dt equal to minus dA by dt equal to plus dB by dt, and dx by dt is the rate of reaction, and the rate of reaction dx by dt is equal to minus dA by dt equal to minus dB by dt, since the reaction is in 1:1 proportion. So here rate of A equal to rate of B, but here minus dA by dt and plus dB by dt. The rate here is 2 times of rate of reaction, here 3 times of rate of reaction. So in order to make the rate of reaction equal, then I can write here I can write here ROR is equal to one by 2 of minus dA by dt equal to 1 by 3 of dV by dt, and that will be equal to dx by dt. From this I can get, from this I can get dx by dt is equal to 1 by 2 of minus dA by dt, and here I can get dx by dt is equal to 1 by 3 of plus dB by dt. So this is the stoichiometry calculation for a rate of reaction. Again, for a reaction, here I have 2a plus 5b gives rise to c, that is the coefficient of a is 2 and coefficient of b is 5 and coefficient of c is 6. How to know that? When 2 moles of a will react with 5 moles of b, then 6 moles of c will be formed. So here I can write, when time t is equal to 0, initial concentration is a naught and it is b naught and it is 0. When time t is equal to t, the concentration left after time t, that will be a naught minus 2x. Why the coefficient is 2? Here b naught minus 5x and 6x amount is formed. So here I can say that rate of A equal to minus dA by dt equal to a naught minus 2x minus a naught divided by minus d by dt, sorry it is not d, equal to 2 times dx by dt equal to minus dA by dt. Similarly, rate of b is equal to minus dv by dt, and that will be equal to minus d by dt of b naught minus 5x minus b naught divided by, sorry not divided, equal to 5 into dx by dt, that will be equal to minus dv by dt. Similarly, rate of c is equal to minus, sorry plus dc by dt equal to d by dt of 6x minus 0 equal to 6 into dx by dt, that will be equal to plus dc by dt. So this is the rate of consumption of A, this is rate of consumption of B, and this is rate of consumption of C. But what we have seen here, the rate of disappearance or appearance of individual product is not same here. So I can write here the rate of reaction, that is dx by dt is equal to, in order to make all the rate of reaction equal, or dx by dt is equal to, I can simply write 1 by 2 of minus dA by dt equal to 1 by 5 of minus dB by dt, that equal to 1 by 6 of plus dc by dt. So when it means that the rate of chemical reaction depends upon stoichiometric coefficient of a chemical reaction. Remember, it means that the rate of a chemical reaction depends upon stoichiometric coefficient of a chemical reaction. But for a particular species, the stoichiometric coefficient is not required. So in general, I can say that, let us consider a reaction alpha A plus beta B here. Let us consider reaction alpha A plus beta B gives rise to gamma C. So here I can write that rate of reaction is equal to dx by dt, that is 1 by alpha of minus dA by dt equal to 1 by beta of minus dB by dt equal to 1 by gamma of dc by dt. So for a reaction 5A plus 6B gives rise to 8C. So rate of A, so here again the rate of A I can write here minus, sorry, here I can write the rate of A is equal to minus dA by dt. While writing the rate of A, I don't require any stoichiometry, but while writing rate of reaction, I have to require a balanced chemical equation. So rate of reaction, I can write for that reaction, that will be 1 by 5 minus dA by dt, that will be equal to 1 by 6 minus dB by dt, and that will be equal to 1 by 8 plus dc by dt. So here you have to note that it means that the rate of a chemical reaction depends on stoichiometric coefficient of a chemical reaction. stoichiometry. The rate of reaction always depends upon stoichiometric coefficient, but rate of a chemical reaction of particular species does not depend upon the stoichiometric coefficient of a chemical reaction. For a particular species, we don't require stoichiometric coefficient, while in order to calculate the rate of chemical reaction, overall reaction, we require a stoichiometric coefficient. Simply see this. Here asking is rate of A, but here asked rate of reaction. So for rate of reaction, we have to calculate, we have to know the balanced chemical equation, but calculate the rate of A, we don't require any stoichiometric coefficient. So here we are going to solve a problem regarding rate of reaction. So read the question. For the formation of ammonia, the rate of consumption of N2 is 1.5 into 10 to the power minus 3 molar per second. Calculate rate of reaction. By seeing the question, I can say that the question is incomplete. The question is incomplete. Why for calculating rate of reaction, I need balanced chemical reaction, but here the balanced chemical reaction is not given, so the question is incomplete. So make the question complete. Although you have already started solving the problem, but the problem can be solved as follows. Since the reaction is not given, I can create a reaction like this. N2 plus 3H2 gives rise to 2NH3, or like this, half N2 3 by 2H2 NH3. Like this, 2N2 plus 6H2 gives rise to 4NH3. Any of the reaction is balanced chemical equation. Given, what is given here? Given here, the rate of consumption of N2 is 1.5 into 10 to the power minus 3 molar second. That is, I can write here minus dN2 by dt. dN2 by dt is given here. So for each and every reaction, I have to write rate of reaction. Rate of reaction is equal to minus dN2 by dt equal to 1 by 3 of minus dH2 by dt equal to 1 by 2 of dNH3 by dt. So here rate of reaction equal to 2 times minus dN2 by dt equal to 2 by 3 times minus dH2 by dt equal to dNH3 by dt. In similar way, here I can write the rate of reaction, that is 1 by 2 minus dN2 by dt equal to 1 by 6 minus dH2 by dt equal to 1 by 4 dNS3 by dt. So we have to calculate the rate of reaction. Since the rate of reaction equal to minus dN2 by dt, I can simply write here rate is equal to 1.5 into 10 to the power minus 3 molar second. That is for this reaction. And for this reaction, I can write here rate is equal to 2 times of minus dN2 by dt. So 2 into 1.5 into 10 to the power minus 3, and that will be equal to 3 into 10 to the power minus 3 molar second. And for this reaction, rate is equal to 1 by 2 of 1.5 into 10 to the power minus 3. So I can write here 0.75 into 10 to the power minus 3. So for all the three reaction, the rate is different. Here the rate is 1.5 into 10 to the power minus 3 for this type of the reaction. Here the rate is 3 into 10 to the power minus 3 for this reaction, and here the rate is 0.75 into 10 to the power minus 3. So for all the three reaction, the rate is different. So for the formation of ammonia, for the formation of ammonia, rate of consumption of N2 is 1.5 into 10 to the power minus 3 molar per second. Calculate rate of reaction. The rate of reaction depends upon a chemical reaction depends upon stoichiometry of the balanced chemical reaction. Since the question is incomplete, so the rate is also different. All the rate will be correct depending upon the balanced chemical reaction. If you want to calculate the rate of individual species, it also be same. Let us calculate the rate of dH2 by dt in all cases. Let us check. Here I can write that rate of reaction is equal to 1 by 3 of minus dH2 by dt. So minus dH2 by dt is equal to 3 times of rate, or minus dH2 by dt is equal to 3 into 1.5 into 10 to the power minus 3, and that will be equal to 4.5 into 10 to the power minus 3. This 4.5 into 10 to the power minus 3 is the rate for dissociation of hydrogen. Again we have to calculate for this reaction 1 by 2 N2 plus 3 by 2 H2. Again here minus dH2 by dt is equal to 3 by 2 of R. So I can write here 3 by 2 into what is R? R half 1.5 1.5 into 10 to the power minus 3. Sorry, I made a mistake. Sorry, I made a mistake. What is that mistake? Here, for this reaction, I have calculated the rate, that is 3 into 10 to the power minus 3 molar per second. So for this reaction, minus dH2 by dt is equal to 3 by 2 into R, that will be equal to 3 by 2 into R, and R is 3 into 10 to the power minus 3 mole per second. So 3 3 is 9 divided by 2, I can say that 4.5 into 10 to the power minus 3 mole per second. Again I have to calculate for this reaction. For this reaction, 2n2 plus 6h2 gives rise to 4nh3. For this reaction, minus dH2 by dt equal to 6 times of R. For this reaction, R is 0.75. So 6 into 0.75 into 10 to the power minus 3, and its value will be 4.5 into 10 to the power minus 3. So why I am giving this question? This question simply calculates the rate depends upon the stoichiometry, and the rate of individual species does not depend upon the stoichiometry. The rate of a chemical reaction depends upon stoichiometry, whereas the rate of individual species does not depend upon stoichiometry. So by seeing this, you can easily calculate or easily solve this problem. For a reaction 2A plus 3B gives rise to 5C, the initial concentration of A is 10 molar, which changes to 5 molar in 20 seconds. Then calculate rate of reaction of A and the rate of reaction and value of minus dV by dt and dC by dt. You can easily solve. Thanking you.